So the question is, why do we have these special triangles? Why do we memorize these in the first place? And the reason is because pre-calculus and calculus curriculum right now, at least in the United States, is such that the convention is that we all have certain trigonometric values, like sine of pi over 3 to be a known value. We need to know exactly what it is. Sine of pi over 4, sine of pi over 6. That way the calculations go a little bit quicker in calculus. You could always use a computer to use a decimal approximation, but the way things are right now, we don't do the decimal approximations in our calculus and pre-calculus. We're asking students to memorize these values. Okay, so there's these triangles. Why these triangles? Why not some other triangle? Why are they these particular measurements? It's because we're drawing these triangles in the unit circle. And again, you could have drawn them in a circle of radius 2 or radius 3, but it's just another one of those conventions, another one of those just rules that we've all accepted, even though there could be other rules in place. Okay, so a unit circle is a circle with a radius of 1, but you could certainly do this for a radius of 2 or a radius of 10. You could find out particular values, but they'd still have the same ratios. You'd still get the same thing. Sine of pi over 4 would still be square root of 2 over 2, even if it wasn't this special triangle. Because look down here. I drew another triangle. This is 1, 2, square root of 3 for measurements, and let's say we want to know what angle theta is. So you could use any of the 3 basic trigonometric functions. And so I'll just use sine of theta. Sine of theta is supposed to be whatever is opposite of theta, which is a 1, divided by the hypotenuse of the triangle, which is 2. And if I solve for theta here, I need to use arc theta. I need to use arc sine. I need to use inverse sine. So you could write it like that, or the more computer-friendly way is arc sine. Because they're inverses of one another, that makes it cancel out when you use arc sine on the left. Okay, arc sine of sine just makes theta, and we did the same to both sides over here. And so if you plug this in a calculator, if you do 0.5, and then if you use trig second to get arc sine, it gets 30 degrees. Right? And that's the same thing as what we have up here, except the only difference is that I scaled up the triangle. I multiplied everything by 2. Multiplied this by 2, this by 2, and this by 2. So it's a similar triangle. So you get the same thing with this triangle as you would with this triangle. There's an infinite amount of triangles that you can make to tell you what angle would make your sine ratio equal 1/2. Okay, but we're just trying to make life easier for students by saying, hey, let's just memorize these two. That way we have all the basic trigonometric values that we're supposed to have for sine and cosine, for all those things for calc and pre-calc. Okay, so I hope that gives a little bit of clarity. It's still probably confusing because as a student, I remember saying, why are we doing it this way and not this way? And I didn't have enough instructors telling me, you could do it that way. It's just not our convention. We've all adopted words that we use in the English language. We've said that the word bus means that big yellow thing that comes and picks up kids in my neighborhood, right? And so it's the same thing with these special triangles. We've all just decided to draw them in the unit circle, but you could memorize these values with different triangles. This is 30 and this is 60, and you've still got the same answer for theta regardless of the situation.